All right, this is your stats sensei, Mr. Spencer, and we're going to do the Chi Square units of fit for scenario 4. So the number of televisions that American families have is distributed as follows. All right, 10% have none, 16% have one, 55% have two, 11% have three, and 8% have four or more. A random sample of 600 families in the far western US resulted in the following table. Well, they came up with 66 out of 66 had 0 TVs, 119 had one, 342, 60 had three, 15 had four or more. And when we totaled those up, and they didn't do it for us, we ended up with 600. Well, what did we expect? Well, we had 600 total, so we'd expect 10% of that 600 or 60 to have 0 TVs. We would expect 16% of that 600. That should be a 0.16 right here. We'd expect 16% of that 600 or 96 to have one TV. We would expect 55% of the 600 or 330 to have two or more, two TVs, et cetera, et cetera. So that gives us our expected values. The percent, this was basically multiplying times 600. All right, these percents times 600 gave us our expected values right here. So at the 1% significance level, does it appear that the distribution, the number of televisions of far western US is different from the distribution for the American population as a whole? The null hypothesis, the distribution of TVs for the western US is the same as the whole US. The distribution of TVs for the alternative, the distribution of the TVs for the western US is not the same as the whole US. Conditions, random sample, they gave it to us. We need to address the 10%. So N is less than 10%. So 600 divided by 0.1 is 6,000. And we need to say that there are at least 6,000 families in the western US. And there's much more than 6,000 families in the western US. Our expected values, they're all greater than 5. Matter of fact, our smallest one is 48, so we're not even close. And then our observed values, and by the way, expected can be decimals, but the observed values have to be whole number counts, okay? So degrees of freedom. Well, in this case, we have 1, 2, 3, 4, 5 categories. So 5 minus 1 is 4. And our equation is observed minus expected squared over expected. All chi-squareds are going to have that particular equation. So in this case, I've entered the data. I went to stat edit in 66, 119, 340, et cetera, and input all the data. Then I go stat test all the way over to letter D, which is chi-squared goodness of fit. And when I do, and I press enter, my observed data is in L1, my expected data was in L2. In this case, I had 5 categories. So my degrees of freedom is 5 minus 1, categories minus 1. And I end up getting a very large chi-squared at 29.6 and a very small p-value. Please be careful. We never have p-values greater than 1, so make sure you look. In this case, we're going to have 5 zeros. So if we have 5 zeros, then it's approximately 0. Then we have our contributions down below. So in this case, our p-value is 0, which is less than 0.01. We reject the null. So our p-value is approximately 0. We reject the null. There is sufficient evidence that alpha equals 0.01 to suggest that the television ownership in the western US is not the same as the US as a whole. Once again, a restatement of the, this is just a restatement of the alternative hypothesis. We reject the null television owner in the West is different than the US as a whole. Our contributions that were listed below at the bottom of our calculator, those, when we sum them up, will sum up to the 29.65. And when we look at this, we can see that 22.688 contributes the most, all right? we expected there to be, and when we look at the table, we expected there to be 48, when in fact there was only 15. All right. We expected to be 48 when in fact it was 15. And do remember, you can always do the first one and the last one. So this is our first one, 66 minus 60 squared. We were expecting 60. Here we had 15 minus 48 squared over 48, because we had observed 15 and we expected this. And this one had our highest contribution. All right. Hopefully that helps with chi-squared goodness of fit. And I will see you on the next one, which will be talking about chi-square test of independence or association. Thank you.